Okay, good morning. Everybody should be in their seats. Good morning. Happy Halloween. I'm not going to even try to compete with the ghouls and goblins and things today, but I'm good to have you in class this morning. I have a handout for you. I know we've been looking at quite a bit, discovering the idea of quantities and proportions and comparisons and those things. I have a handout for you I'd like you to take a look at. We're starting a new unit today. It is dealing with similar figures. And I want to get some idea from you. You're welcome to talk with a neighbor. Pass those back. Now, you're going to need some rulers for this exercise. So get a volunteer to come up and hand out the rulers for me. Thank you, sir. Give me personal rulers. I need you to take out a separate piece of paper. Put your name, date, and period on it. Mr. Williams is going to use that today, so I can get an understanding of what you have learned today after our time together, and demonstrate for me some things about similar figures. As you're working on that, please look up here for a second. I always like to introduce our goal whenever we start a new unit and where we should be. Everybody look up here, and I've said this before, the standard and understanding the standard allows you to know where you're going and whether you have arrived. All eyes up here, please. Very quickly, I'm just going to read it, give you some ideas to think about. Okay, it is GSRT2. Given two figures, use the definition of similarity in terms of similar transformation to decide if they are similar. So we're going to be looking at similar figures, polygons. And so take a moment. You can talk with a neighbor on this assignment. Use your ruler. Look at the first thing I have on the handout. Think about what we've been looking at, proportions, measurements of figures you've been doing lately, and see if you can answer those three particular questions. I'll give you a few minutes. Don't forget the one on the back. Started to give you, in respect of Halloween, started to give you a back problem, but I'm going to be contrary to that butterfly today, okay? Yeah, you can write on it. You want to answer question 1 at the top. Based on the measurement above, how can we relate the images shown? Somewhere on that paper. We've been looking at ratios, proportions. Now, in the problem with the polygon, quadrilateral, you want to get an approximate measurement. Okay, on the butterfly, you talk with a neighbor, use your ruler, you need to measure something, or several things, and attempt to draw the real butterfly. Okay, just a few more moments, and we'll take a look at similar figures. I see some good representations of butterflies. For number 3, I want you to list your dimensions for the actual real butterfly.
They give you those dimensions.
What will be the approximate dimensions of the real butterfly? Okay, let's look at all eyes up front. Are you still working at it? Okay, similar figures. We're trying to discover some ideas here. Okay, let's look at number 1. Based on the measurements above, how can we relate or compare the images shown? Why am I using the words compare and relate? What are they synonymous to? Some of the things that you've been doing lately. How do you compare or relate quantities? Anybody? Any ideas? Yeah.
You look at corresponding sides.
You look at corresponding sides. Good idea. Anything else? How would you compare those corresponding sides? Yeah. A ratio. Very extremely good. Everybody realize if you look at number 1, based on the measurements that we see, you can relate these two figures by creating a ratio. Okay? And what would that ratio be? What would the ratio be corresponding? What sides on the figure are look corresponding? Okay? Good, you mentioned ratio. And we can see that the larger cup is 6. And the smaller cup is what? 4. So we can compare them by creating a ratio of the corresponding length. Extremely well. If you've got 4 over 6, and do we want to leave it there? We want to reduce it, and it becomes what? 2 over what? 2/3. How many got that? All right, that's the answer to the first one. How about the diameters? Not only can we compare the size of the cup, but we can look and create a relationship or a comparison. That's what a ratio is. If you want to compare and contrast things, okay, shapes, you want to create a proportional ratio, and that's what we've been doing. When you say a ratio or proportion, you are comparing two items. You're comparing angles or sides. And so we can see if we compare even the diameters. We can see the diameters the ratio would be what for the diameters? Okay? Similar. You can see one diameter, the larger cup is 6, and the smaller cup is 4. We see that diameters being compared is exactly the same scale as the size. Very, very good. Let's look at number 2. Let's get someone to come up to the board for number 2. And let's look at the question. Measure the pairs of corresponding sides with a ruler. What can you conclude about the ratios? And that's what, Mr. You discovered that word this morning, I didn't. That a comparison, contrast can be done with the ratio, creating a fraction, numerator, denominator, with the corresponding sides or angle. And then look at number 2. You use your ruler. We just want to approximate things. Okay, sides with the ruler. What can you conclude about the ratios once we get the sides? Let's get some sides going here. Anybody got an answer about the sides you measured? Approximately? Okay? Yes, come on up, sir. Can you put the sides in for the first polygon? Okay, what does that round to? I want to round, what was it approximately? How many got approximate number? What was it? It was 2, so why don't we put 2 inches here? Yeah. Was that 2 inches for the smaller one? No, it was 1.6. Okay, good. Who did it in centimeters? Okay? Very, very, very good. If you measured everything in, what did you get for the larger? Come on up and give us the measurements on the larger. If you did it in centimeters, it was a lot simpler. Okay? Okay, very good. Everybody see the measurements that are here? Okay, now let's look at the question. I want someone to come up and see what we can discover. We looked over here and we saw that we can relate different figures by creating a ratio of the corresponding sides or diameters or angles, okay? And then we come to number 2, where we have 2 polygons, they're quadrilaterals, and we measured both sides. We measured the corresponding sides. What can we say? How can we compare the 2 figures? We just figured that out. I want you to volunteer up. Let's answer the question. Just talk with a neighbor, see what they got for the question. Measure each pair of corresponding sides with a ruler. What can you conclude about the ratio of the corresponding sides? Anybody got any idea? What can we conclude? Anybody work it out? I want to get on someone we haven't heard from. Anybody? Yes. I didn't hear you. The ratios are congruent. Okay, everybody got that? Congruent to what?
Wait, all angles, all ratios of corresponding sides are equal.
Okay, can someone give us a figure? What have we determined? How do we compare the 2? What did you come up with? Let's look at the first corresponding sides. Which sides are corresponding? If you can look at the figure. Okay? Corresponding sides. Everybody see that FE corresponds to what side? Number 1. FE would correspond to what side? Emil? And if you compare the larger quadrilateral, okay, which is ML compared to FE, what do we get? We get what? 1.5, okay, approximately, and 0.7. What is this approximately? Yeah. 2. How many got that? Put a thumbs up in the air. You'd have gotten 2. Well, let's look at the next one. Get an idea what Mr. Williams is talking about. This one, if we look at comparing the same figures, we see that what? That MN can be compared to what? FG? Okay, what do we get? We get what? 3.2 over 1.6? What is this approximately? 2. Anybody see a pattern? Do you see it yet? Let's go to 3. Let's compare the corresponding side here. The larger figure. We've got NO compared to GH. Okay, what do we get? We get 2.5 inches over 1.25. What is it approximately? What is it approximately? 2. Let's look at the last corresponding side. It's the horizontal side of the polygon, and we've got the larger is LO compared to EH. 4.1 inches over 2.1. What is it approximately equal to? What is everybody? What's the pattern here? Yeah.
The ratio is 1 to 2.
The ratios are what?
Is 1 to 2.
Are 1 to 2. The corresponding sides in proportion are all equal. What does that tell you about these two figures? Did everyone hear that? These figures are similar. That's what similarity is. But let's not stop there. What could you imagine about the angles? Yes. The angles what?
Are congruent.
The angles are congruent. Let me write down the definition. I want you, because you discovered it, I'm going to write it down with you. That when we talk about two figures, okay, there are two conditions. A, corresponding angles must be congruent. And then number 2 and B, corresponding sides Everybody got it? Thank you. That was excellent. You've discovered what similarity is. It's when two figures possess corresponding angles are congruent, and the corresponding sides are what? Proportional. That's the definition. That's what we're looking for. That's what we're aiming for in the standard. Let me give you some other things that we discovered. Now, what can you say? I want you to talk to a neighbor. What do you think happens with the perimeter of similar objects? Just talk with a neighbor briefly. I just want you to think about that. You've got, if you measure them in centimeters, many of you know this, and who has a definition, who has the measurements in centimeters here? Yeah, what was this? This was what? 2? What was this? 4, 3, and what? 5. Okay? For those of you, what was this?
4,
This was 4, 8,
6,
6,
10.
and 10. Just to make it easy. I want you to talk with a neighbor right now. What do you discover about the comparison of the perimeters of those two quadrilaterals? I want you to quickly figure that out. I'll give you a moment to talk with a neighbor. When we compare the perimeters of similar polygons, what have you discovered? Okay. Okay, who has it? Raise your hand. Who has it? Who has the key? What can we discover about the relationship or when we compare the perimeters? What do we get? Yes, sir.
The one on the right has double the perimeter of the one on the left.
Did everybody hear that? Oh, it's amazing. Let's take a look. Perimeter of polygon 1. How do you find the perimeter? It would be what? 2 plus 5.